Good morning, Scouts. Welcome to day 2 of the mapping workshop. Good to have you all here. I think, as with yesterday, I'll just give everything a few minutes to make sure that people are online, and we just get some hands up in the WhatsApp group. I've been seeing a few already. The people are already tuned in. So yesterday we obviously went through all the requirements for the map reading Scoutcraft badge. We obviously have the 2 videos out for yesterday. Any of those of you who are just joining us today for the first time, welcome. If you already have your map reading badge, then awesome, you don't need to go through anything else. But if you'd like to brush up on any of the things that are covered there, you're welcome to check out the videos. The links are on the WhatsApp group and available on this channel. I will be spending a little part of this morning's session just running through a few of the points quite quickly, just so that we are all on the same page if we do need to come back to those points later. I think that's most of the housekeeping. Again, for any of you who didn't join us yesterday, just the way this weekend's process is going to work. Obviously, if you've got any questions as I go through things, please feel free to drop them on the WhatsApp group. We'll get them from there, and I'll do my best to respond to them in detail as we go. Obviously, examination for these badges ultimately involves us doing a lot of practical things, which means that after the lockdown is over, we are going to organise either just a day or a weekend to meet up and go through the requirements. The nice thing with the 2 big ticket items on the mapping badge is that you can probably do some of them in your own time, and there are actually going to be some cool ways that you can practice them on a very small scale in your own house or your back garden during the lockdown. So you'll at least be able to put a little bit of practice in place for these requirements. That's the 2 big items I'm talking about, being the strip map. And then this afternoon session is going to be devoted to playing tables. When we get to points that when we finish each of those sections, I'll give you some ideas as to how you can go about doing some homework and learning what's actually going on. Anywho, I think that should be it. I think we've got quite a few people online and following, so I think then I'm going to get cracking. So, first things first. We've got a couple of requirements for the mapping badge that we actually went through yesterday. What the Scoutcraft badge. A couple of them are either rehashed in the mapping badge, or we just went over and above yesterday, which also seems likely. So I'm just going to run through some of those requirements and give a very brief recap on them. We talked a bit yesterday about map scales. Perhaps I should go a bit more detail there. Obviously, all maps are published at a particular scale. We obviously dealt with our 150,000 topographical series, as well as the ortho photos, and discussed that there are a whole different range of scales out there. The big thing to take away from that is that to always check what map scale is before you use it, but also to pick the right scale of map for your task. If you're trying to plan a 4x4 trip to drive from Joburg to Cape Town, but like using back roads, trying to do the entire thing with 1 to 50,000 maps is going to get quite tedious. If you try to join all those maps together to do Cape Town to Joburg, you'd need a pretty big parking lot to put them all in. I at one stage had 1 to 50,000 maps of the Drakensberg as wallpaper. It takes quite a bit of space. Right. So always pick the right map for the task. Obviously, scale is important there, but also the type of map and the detail that's found on it. There's no point picking up an old geological map and trying to use that as a navigation map. That's not going to be fit for purpose. We talked about the numbering systems of maps in the South African mapping system. We spoke about this here big the big pink booklet that gets put out which is effectively the National Geospatial Institute's Directorate of National Spatial Trig survey that they put out. Effectively the catalogue of the products that they make, and it is the list of all the maps that they produce. You can either get them directly from Trig Survey if you're in Cape Town, head on through to the offices in Mowbray. You can also get them from the government printers in Pretoria. I don't know where the actual address is, but I do know that I've successfully gotten maps from there before. But the place that I recommend if you're in Joburg is you head through to a shop called Maps for Africa in Craig Hall, just on Jan Smuts Drive. And they are very, very friendly, very, very good. They've usually got most areas of South Africa in stock. If they don't have them, they will get them for you on order. Obviously, they keep more of the really popular hiking areas, but those maps also go faster. So yeah, head on through there and have a chat to them if you're ever needing any kinds of maps, but specifically your topographical maps. We also spoke about the numbering system, using the latitude and longitude coordinates. I'm not going to go through latitude and longitude again. Fortunately, my balloon that we'd used to draw all of that on got popped by my cat. So that was the end of that world. And you say the numbering system, obviously latitude and longitude, and then the ABCD structure. That also flows down to your 1 to 10,000 orthophoto series, where there are 25 orthophotos to a topographical map. I think that is it for the numbering system, and a quick recap there. We've spoken about that. Right. The next point here is actually to go through contours and slope profiles. We went through that quite extensively yesterday afternoon, so you can check out the Scoutcraft badge part 2, but I'll quickly pull it up for us and we can flick through what we did there just to remind everyone. And I'll say this will be skimming through this. If you do have questions, please check out yesterday's video. We did go through it quite in detail. Let's do that. Right, so here we have a little hilltop that we wanted to draw a slope profile of, or a cross section. If we were doing this in real life, we would do it by holding our piece of paper along the line that we wanted to draw our cross section. What we would do is we would go through and make tick marks every time our line crossed through a contour line, which we've now gone and done here. I just used a different color in my lines here to indicate every 5th contour, which is our 100,000. which is our 100 meter contour intervals, as well as a pop little green line there in the middle just to remind me where we stopped going up the hill and started going down the hill again. So say I've got rid of the map and I turned my line horizontally, and then what we did was we started adding, we drew ourselves a whole bunch of grid lines, and at every tick mark here we went up a grid line. And as we can see, when the contours were further apart, the line was relatively flat. When they were quite close together, the slope was quite steep. So for a bit of homework for Plotting with this badge, what you can do is grab any 1 to 50,000 map that you have lying around. If you don't have one, we are organizing to try and share some digitally with you. Just pick a interesting bit of topology and start figuring out drawing a cross section. One thing that's quite cool that we can do is I'm just going to zoom in a smidge here. I'm sure you've all been hiking at some point, and you think you're coming up to the peak, and then you crest over this peak and realize that it wasn't a peak, it was a false peak. And that's caused by sections like this over here. So here we're going up, now this bit gets a bit steeper, and while I'm walking up this, I just draw a line in here. Let's see if this works. If I draw a line along here, oh no, it wasn't supposed to be there at all. Give me a moment. Why is that not going where I want it to go? Sorry, something's a bit weird. What I'm going to do, just so that this doesn't move at all. Right, apologies for that. Let's hope this works a smidge better. No, that's still being pretty weird. Sorry guys, something's going a little bit weird with my drawing on my screen here. Right, what I'm going to do, let's try and just place this into position. Right, so what I've done here is I've taken this line and I've drawn a line along here, exactly along the line of that slope. So if I'm walking up that slope and I'm looking forwards, that's what I'm going to see. And you'll notice I actually can't see any of this part of the mountain because we had this steep bit and then it flattened out a bit and then went up again. So as I'm hiking up here, I might think this is the top of the hill because I can't see any hill beyond it. But what happens? As soon as I crest over this bit, I see, oh dear, there's actually more hill. All right. And that's one of the things that doing cross sections can help you with. You can actually figure out if you if the hilltop that you're seeing is indeed the correct hilltop or not. Right. So as I say, that was a very quick catch up on contours and doing cross sections. There is actually an explicit requirement for the mapping badge. I think we just covered it yesterday out of interest in demonstrating exactly how contours work. But if you would like to, as I say, do that as part of your homework, you're more than welcome to. Right. So let's move very swiftly then on to strip maps. So what is a strip map? And maybe this is just a good time just to talk generally, before we dive into strip maps themselves, about a couple of the golden rules that apply to maps. So whenever you're making a map, and I've I've actually made a few maps for orienteering races in my time. There are two very key rules that apply to any map, any scale that you're working on, any type of map that you're making. And these are the rules. If it's significant in real life, it should be significant on the map. And if it's significant on the map, it should be significant in real life. Now what do I mean by that? If you take a map, and the map says that there is a river in a particular place, I should be able to get to that particular place and go, look, there's a river. And similarly, if I'm hiking along and I come across a river, I should be able to find that river on the map. Obviously, you do this within the constraints of your scale, but so there might be things that are actually too small to show on a map. But then for that map's purposes, that item is not significant. If you another good example that I often come across with orienteering maps is a boulder. So if you mark on your map, there is a boulder along this route, and I'm running along in my orienteering race, and I see a boulder in Rocklands, and there's only one boulder labelled on the map, then I should go, well, I'm by the boulder. So if you label a boulder on the map, it shouldn't be that there is a tiny little pebble on the floor. A boulder should mean a boulder. And the flip side applies as well. If I run along and I find a boulder and there's no boulders mentioned on the map, I should start to worry that maybe I've run off the map, for example. I'm no longer where I think I am. So that rule of important in real life means important on the map, and important on the map means important in real life is going to apply to any kind of map we make. A map is a means of conveying via a graphical and pictorial representation to somebody what's actually happening on the ground. So we need to make sure that we're preserving that. All right. So what is a strip map? A strip map is kind of what it says on the tin. It's a map of a strip, of a thin piece of area. Typically, these would be made along a route, either as you're hiking along a path, following a river, following a pipeline, whatever the case is. It's whatever along our strip, and all the things that are important to us that we can see to the sides. So to help demonstrate some of this, I'm going to pull up actually a very useful article on the Scouts Wiki that has been put there by, as far as I can see, Kite from First Henley. So shout out to them for putting this out there. And let's flip out display over there. Cool. So if you're interested, you can check this out on scoutswiki.scouts.org.za. Just have a search there for strip maps. This is an example of a strip map made of a route on the road. And you're going to notice a few key things that are going on here. You'll see here there's this strip map, and the strip map is effectively just a straight line, right? There's a couple of wiggles in it, but they've drawn their route, so from start to finish, as basically a straight line. And all that they've put in here is where there are crossings. If we look at this route, so they went from their scout hall to the oval. And on this little map here, let me zoom this in a bit for you guys. Here we go. So they went from their scout hall to the oval, but you can see there's actually quite a wiggly route going on here. So what's actually cooking? Well, what they've done is they've said, well, we're going to draw this route out, and instead of orientating our map towards north, we're going to orientate our map in the direction that we're actually traveling. So whenever they hit a corner, which they did here, they're going to completely exaggerate the bends, so that the bends keep turning them into the same straight line. See, there's a corner there. They went across the river here, and if you're just thinking of this as a normal map, they'd say, well, hey, I'm walking in a straight line, but actually that river, the road where they're going across the river, is completely at 90 degrees to where they started off. All right. They've still shown the corners. Sometimes people make a mistake with a strip map of not showing corners. But this is the method they've used here. See, there was another corner over there, and they denoted that over there. In fact, they've actually put little tick marks to say where the actual corners are, and they've got the distances noted here. So to there was 980 meters. There to there was another 435 meters. There to there was another 870. Now, another thing you can notice here is that they have they're not using a consistent scale. That's another feature of strip maps that often gets used. We'll talk a little bit about some of this bit later. There are different ways of doing this. But it's quite a common method with strip maps to distort the scale to show things relative. So here, the distance that they've used here to show 900 meters is actually fairly similar to the distance that they've used here to show 400 meters, and again to show 870 meters here. So anyway, this is one particular method of doing a strip map, and as I say, they've distorted their lines and their corners a bit. But I've actually got a couple of examples, and we'll talk about all the different examples first before talking about what is kind of right or wrong. So this is a signboard that I saw whilst on a hike. This is at Bethlehem Nature Reserve out near Bella Bella. And it's a really cool place to go hiking. And they have this little signboard. And what's on this signboard is effectively a strip map. So again, you can see we've got our distorted scales here. That little line segment there is 1.2 kilometers. And that little line segment there, which is pretty much the same distance, is 0.6 kilometers. So it's actually half as long as that in reality. Now, why would you do this? Why would you start messing around a bit with the scales? And that's because this would be a really long section here of nothing much very happening. You can see here there's a 2 kilometer stretch. And there's actually not a lot happening in that 2 kilometer stretch. So there would be no point showing this really long 2 kilometer stretch with nothing much happening. You're just wasting space on your paper. You'll see here that they have kept the integrity of the corners. And actually what I'm going to do is show you what this area actually looks like in reality. So I went onto Google Earth and I grabbed some satellite imagery. And this is the actual area. And what I'll do now is just put the two side by side. So I've rotated let me just bring this across a bit. So, well, first of all on here, north was upwards, if you like. And so I've just turned north so that it's sideways, because a strip map you always use the length of your piece of paper or whatever you're drawing your strip map on to show the direction of travel. Doesn't matter really which direction north is. You're going to keep the direction of travel as upright. You can note north on if like this one where you by and large preserve direction. But on our earlier example where they didn't preserve direction, then it wouldn't make any sense to put a north arrow on. But let's have a look here. So we can see that, zoom out a smidge there. So our entrance over here is now down at the bottom, and this hut up here is up here. And you can see it is a relatively straight line, which is what they've kind of drawn here. But let's do this. I prepared this a bit earlier. And here you can actually see I've lined up the object. So you can see here you've got this relatively short distance, quite a long distance over there. And this distance, which looks the same distance over here, is actually quite short on this one. You can see here on the map, the road does a little bit of a bend, but it's kind of not that significant in the grand scheme of things. We're going straight, then we went left and then right, in relatively quick succession, which they've then not shown on the map here, because it doesn't necessarily add too much value to them. Over here, however, we've got a relatively big bend, and we kind of continue off in a different direction. So they have shown that corner. And what you'll notice here is that they've spaced out quite a few things here, so that they can actually show where they are. And those lines are actually really, really close together over here. And that's one of the powers of using the distorted scale for the strip map, because sorry about that. Because what it means is you don't need to waste all the space showing your 2 kilometers stretch over here and then have to cram everything that's here into a tight little space. You're able to blow up the areas that need blowing up and shrink down the areas that need shrinking. So just maybe a few other key things that they've done here is on this map they've been, well, if we go back to our first example, let's see if I can do that. Quickly pull that back up. So on our first example here, they made sure to show other roads that they crossed, right? Because that's significant navigational features that you can use if you're actually on the road. But here, they made sure to show things like rivers over here, and the rivers over here, as well as the huts that people might encounter. Because those are things that people are going to be able to see from the road, and be able to use as navigation to say, I know I'm in the right place. They also added a little cell phone symbol here to say, hey, there's actually some reception here. So if you need to get cell phone reception, you know where to find it. So that's one of the key things that you're always going to try and achieve with the strip map. You're not just drawing the road, you're also drawing the things that you can see from the road. So the way you would typically make one of these is that you would start off and you'd start walking, and you'd obviously keep some notes, what bearings you're hiking on. If you're doing this as you go along with your hike log, obviously taking your bearings so that you can make your maps, or make your hike log. But as you're going along, right, we walked 500 meters, and on our left we passed a reservoir. And we walked another 300 meters, and we stopped in the shade under a big tree. That would be something that would be relevant if you're hiking. It might be very useful to people who are going to use the map afterwards to say, good, that's somewhere where we can get shade. But also it's a big tree, it's a significant feature. When we reach the big tree, we know where we are on the map. Yeah, I think that's sort of some of the overarching ideas of strip maps. So for your homework, I guess, you can try and do one of these at a very, very, very reduced scale. If you're sort of trapped inside, you can try and make a strip map of your route from your bedroom to the fridge, or perhaps you've got a bit of a, depending on the layout of your house, you can pick two rooms that are sort of relatively far apart and try and figure out making a strip map as you go between them. Now, how would I actually go about keeping the logs of and keeping my notes of this? Well, actually, before I get onto that, there is another school of thought of strip maps, which tends to require them to be quite accurate. For me personally, strip maps need to convey the information in a clear and concise manner, which is what the ones that we've shown on the screen are doing. But there is another school of thought, which is where we should preserve our scale on our strip maps. And if you're going to do a strip map that style, what you need to do is start taking bearings to objects that you can see. And how would we go about doing that? So, as you're walking along your route, you'd be sitting with a piece of paper, and let me pull up some stuff on the screen here so I can show this to you as we go along. Right. So, where are we now? What we're going to go through now is a couple of the techniques that are often used for when we make plane tables as well, but we can definitely use them when we are making, and we'll go through these methods in a lot more detail later when we do the plane tables in the second video. But for these strip maps, we can use some of the similar methods. And what a lot of this is going to boil down to is somewhat reverse engineering the process we did yesterday when we were trying to triangulate ourselves. So you'll remember that we had three objects that we could see and we found those three objects on our map, and we knew that we were somewhere in the middle of them. So what we did is we took bearing object A, we took our back bearing from that object A to find a line on which we knew ourselves to be, and we repeated that process with object B. We drew a line back on the back bearing from object B, and where those two lines intersected was where we were. And just for safety, we did it with an object C as well, and the lines didn't perfectly intersect, but we were able to hopefully get a relatively small triangle of uncertainty. And when we are doing surveying and mapping, either for this version of strip map that I'm going to show you now, or for the plane tables that we will do in the next video, we will effectively be doing that process in reverse. So when we were triangulating ourselves, we had three objects, and what we had was we had a map that told us exactly how far apart those objects were. What we're doing when we're making a map is we don't know how far apart the objects are. We might say, look, they're over there, and we can maybe it's 200-300 meters away, but we don't really know. but what we can know is its direction. So what we would do is, let's pull my display up here. Right, so this line is the line that we're going to be walking along. Let me actually make it a... oh, nope. Let's put an arrow here. Right, we're going to be walking that direction. And as we walk, we're going to notice a few objects, these blue circles. And presently we don't, as we're walking along, we're going to say, look, there's a blue object over there. I can see a couple of blue objects. But I'd like to actually draw a map to show exactly where these blue objects are. So what's going to happen is we're at the start of our hike. We are going to, where's my shapes? On a particular bearing. So we can draw a line along that particular bearing. If you like, you can just draw your present bearing as straight up the page. But for some of the field work, it might be easier to keep it off on the direction that it actually is. It saves a little bit of calculation when doing the other bearings. Now what we're going to do is we're going to say, look, we're going to take a bearing, and the bearing comes out at about 300 degrees. And we're going to say, look, there's an object somewhere on the line of 300 degrees, right? This object, we see it somewhere along the line of 300 degrees. And from here, we can also see there's an object up here. It's on a bearing of about 350 degrees. And so we draw a line through it. And we can see one out here, somewhere on about 50 degrees. And let's just say those are the only three that we can see at the moment. Then what happens is we decide, okay, we're going to walk along our path. What we do is we measure out how far we walk. So let's say we walk 200 meters. And we get ourselves to a new spot. So what I'm just going to do is I'm going to say, look, there's a little tick mark here. And this line is going to be 200 meters long. So let's write that in. Oop, that is not in no way, shape, or form legible. So we've measured out a 200 meter section. And if you are being clever about this, you'll measure that as you've walked, and you'll say, well, we want to draw this at a particular scale, and therefore we're going to draw that as 10 centimeters, for example. And what we're then going to do is take some more bearings. And this time we're going to look back and see our first blob that we saw, and we're going to take a new bearing to it. And we take that bearing and it comes out at about 260 degrees, and we're going to draw a line. I'm going to say, right, so where those two lines intersected, let me just check for this. So the actual location of this object is where those two lines intersected. All right, so on our map we'll be able to draw in that is where our object is. And we repeat this process. So we look back towards this object and we see that it is due east. And so we draw a line in, say, cool. That is the location of this object. And this object, this is quite a tight angle, so we're going to kind of leave it for now. But what's happened is, well, we can see this new object, so we get a bearing of that, 280. And this one has now come into sight, and we draw a line through it. on whatever its bearing is, 30 degrees or something. And we then repeat the process. We walk another known distance along. Let's say we walk another 200 meters. It's not necessary to always use the same increment, but it is helpful. As long as this object, we now see that it's on an angle of, say, 290 degrees. And this one down here, we've got another angle to that. That's on 240 degrees. 260 degrees or something. And we can also do this one. And with those, we can then label on the map that we've now drawn that these all sit here. And get them onto their exact positions. Oh, no, not move the line. Do not move the line. And anyway, we're then going to walk ourselves another few hundred meters, and oh, lo and behold, another one comes into view. And we take a bearing to that one. But now we've only got one bearing to this last one. So all we currently know is that this object is somewhere along this line. And we must be careful that we don't accidentally think that this line that we drew earlier relates to this one. So it's very useful to label all your lines as you go to tell you what object it is that you're using to get to them. But we would probably have to repeat this process. We'd hike on a bit further. It's going off the edge of my slide. But that you go a bit further, maybe another 100 meters, and then we get another bearing. And eventually we can then place this object as well. Anyway, we've now got a page with lots of lines and lots of markings and whatnot. So what we would then need to do is either transpose this onto a new piece of paper, or hopefully we've done all of this in pencil, and we can then, let me just duplicate the slide, but we can then go through and erase all of our bearing lines and pack away our compass. And now we have a line that we've hiked. Oh, I lost one of my markers. We had another 200 meter marking over there. But now we've taken these 200 meter markings, and what we can, we've now got that all of the position of all of these dots, both in relation to the path and in relation to each other, is correct and accurate. Right. So this method of doing a field survey of your as you're hiking along is very useful. And to be honest, if you're going to be making a map where you do have distorted scales, you probably need to start off by actually producing it at the correct scale, because you're not going to know what is a relevant scale to be using, or what information you can leave out or can't leave out until after you've finished. Obviously, if it's an area that you can go back and forth on, or in the case of the roadmap one, maybe you're using either a pre-existing map book or a some kind of software like Google Earth or OpenStreetMaps to make the route, then obviously you can check it out from that or from aerial photography. You're not necessarily going to know what is relevant, what sections can be distorted, until after you've actually done all your surveying. So for that reason, so some people would say you'd leave it like this, and this would be the end of your strip map. But I would generally suggest that you take it the step further to actually turn it into something that is that conveys the information better, rather than just being left in this form. Right. So when one gets to doing hike logs, especially for first class and Springbok, you'll see that there is a requirement to include strip maps of your route. Now, different scouts are certainly going to have different opinions on this. I don't expect this level of field surveying for the entire route. That is usually unnecessary. But what I would suggest is that you always put in strip maps on particularly difficult sections or particularly confusing sections, because if you've just got a 1 to 50,000 map to navigate by, that might not necessarily convey all the relevant information that somebody else following that route after you might need. So strip maps are something that should be in there to enhance your hike logs and to add information where it's necessary. So your strip maps are the means that you're going to use to do that. To say, hey, we hiked this section of route, and here's the particular information that you really need to know. Maybe there's a particularly wiggly section through a forest or something where there's lots of tracks crisscrossing, and using a strip map approach like this to say, hang on, this is where all the crossings are, this is where all the relevant objects are, might be the best method of conveying that information to the reader. That way they know that if they follow it, they can follow your steps exactly. There's another kind of map that's often mentioned with hike logs. I'll quickly take us through that as well. So the other kind of map that's mentioned in hike logs is what's sometimes called sketch maps. And there's really no useful definition of what a sketch map is, but and sometimes these get confused or conflated. What I would, the way I would interpret these is a strip map is a map that you make as you go along. So as you're following the road, as you're following the river, if you're doing a canoe expedition or something, as you're following along, you're going to be making a strip map because it's going to be what you do and what you can see. What a sketch map is literally you sitting in one place with your paper and going, oh, what do I see over there? 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 A sketch map is probably most useful for doing things like when you've made camp for the evening, just giving a layout of what your campsite looked like. Maybe you want to say, look, the river's over here, and there was a big tree, and there's a nice flat bit of land just next to the big tree. Good for pitching our tents. That might be a valid use of a sketch map. Another cool use for a sketch map, if you think about it, if you've got this short scramble section, you've hiked along and you've reached a bit of a rock face, and you need to do some impromptu rock climbing. Maybe what you can do is you can sit and you can go, well, all right, this is what the rock face looks like, and actually draw the route that you scrambled up. Say, look, there's a good handhold here. There's a good, place to put your foot over here. Don't grab this tree root, that sort of thing. A sketch map is something that's done staying in one place and looking around, whereas a strip map is what you do when you go along. Especially in a hike log, both of those have definitely got a lot of value they can add. The important thing is to use the right type of map for the right purpose, and always ensure that it's adding value. Right. What I'm going to do now is take a 10-minute break. If there are any questions, they can come in now. When we come back, I'm going to take you through actually making a strip map that you can do just in your house, how you would go about it, how I would actually do it with my paper in hand, and making the notes, and then what would actually be expected of you for making a strip map when the lockdown is over and we're allowed back outside. So back in, let's say at 11:05. Welcome back, everyone. Hope you had a good stretch. Hold on. Sorry, I need to close the door. Sorry about that, everyone. Welcome back. Hope everyone had a good stretch and grabbed a drink or whatever you needed. Let's check. Cool. So, a couple of things I want to touch on that I realized I could have touched on a bit earlier. Especially when we're dealing with making our maps, it really comes into play. But it's really useful to think about in the context of reading maps as well. And that is, when we think about the scale of the map, how big are objects that are drawn on the map? And this is another case where we're always going to be distorting something when we make a map. So if we think about our 1 to 50,000 series maps, right, we went through and we said, hey, 1 to 50,000, a centimeter is 500 meters, or 2 centimeters for a kilometer. But if you actually think about it, a millimeter on the map, a millimeter is 50 meters in reality. So sometimes you might look at the map and there is a tree labeled. Now, there's no tree that I know of that's 50 meters wide. Right? So remember, everything we've got here is horizontal distance on those point objects. Even if there's an individual building that's noted, 50 meters is pretty sizable for a building. So have a think about that when you are reading the map, that especially point features are distorted. Even if you think about your line features, the width of the river is possibly 0.2 millimeters at its, that's the printing size of it. Doesn't mean that the river is 10 meters wide everywhere. It might just mean that that's, a rough approximation of the river. Chances are it could be considerably narrower. But that becomes important when you're making your own maps. So, for the badge requirements, the strip map is requested to be at a scale of 1 to 2,000. Now, what does 1 to 2,000 mean? So 1 millimeter on our final map, or 1 centimeter on our final map, is 2,000 centimeters in reality, or 20 meters in reality. Means an individual millimeter is 2 meters wide. So have a think about that when you are thinking about what objects to actually put on your map and how big you draw them. If you can, 2 meters is, a 2 meter wide tree trunk is a pretty big tree. If you're only going to draw that as a millimeter size on your map, you may not necessarily be actually conveying to us that there's even tree there, or have any means to distinguish between slightly smaller trees and bigger trees. So what I would suggest you do there is pick a consistent size for your symbols. Obviously have a legend on your map. Remember that here they had included a legend for some different symbols. So this was a very, very simplistic one with black and white lines. But include a legend with the symbols that you've used, and be consistent in the sizes you use. You might want to have 2 different symbols for. You would want to typically be consistent in the way that you use it. Point symbols especially will almost always be distorted to be larger than the real object is. Similarly with the width of linear features, you would probably end up distorting them slightly. They might only actually be as wide as in reality as a pencil stripe, but you might, actually draw a little region to say, look, there's a river here. And that's why with your point features, such as, on your strip map, especially, doing that distortion of scale allows you to get away with this quite nicely. But it's definitely a fundamental rule of all maps that the symbol sets are almost always distorted in some way. So that was just a little bit that I wanted to touch on with scales and symbol sizes. So, like I mentioned, the actual requirement for this badge is going to involve you making a map of 1 in 2000, and it says it should be a kilometer section of path or route that you do. Now, a kilometer at 1 to 2000 scale will work out to being about 50 centimeters long, which is an unfortunately awkward amount of distance. My suggestion would be 2 A4 pages joined end to end. I'll just grab some quickly out of my printer. A4 page is, for instance, for now, it's about 27 centimeters, 29 and a bit. So 2 A4 pages joined like so should be about the amount of size you need to complete your final strip map. We did a mapping camp a few years ago. We walked from Delta Park down the Spruit towards the Victory Park shopping centre. That is a little over a kilometre and a quite nice route to do. But obviously you can find any strip that you would like to make your strip map of. I'd suggest, although the Henley example was done with a road map, a road area, I'd suggest, just for the purposes of getting the practice and trying something slightly more complicated, pick a piece of Spruit. There's plenty of bits. I don't know how far Bryanston and River Trail halls are from each other, but you might want to try doing the area between those two halls as well if you're from Sandton District. But regardless, what you're going to want to do is these final 2 bits of paper we're going to produce our final map on. But first thing, we need to do our field notes. So to that end, I would get myself a pad of paper, and what I would do is at the start I would just write down my bearing that I'm going to be going on. So making a note, start, and we'll walk on a bearing of 165 degrees. Just make notes. You typically want to just keep rough notes as you go, and as you go, all the information you want to take down is going to be whatever system works for you. I'll show you how I would do things, but there's actually no wrong answer here if you get to the desired final result. So if you start off and you're going on that bearing, what I would then do is, if there are any significant objects that you can see immediately off the bat. So, all right, over there's a power line. Over there's the intersection of the road, whatever the case is. I would then start and write down what that object is. So, power line, and I'd take my compass, and this is one of those cases possibly where your lensatic compass is really going to come into its own. You're not trying to use this with an existing map, you're trying to make a map. So all you really need to be able to do is take bearings to the various objects. So power line, and whatever. Let's just say that's on a bearing of whatever, 130 degrees, and I'm just making up numbers here. This doesn't really matter too much. Power line 130 degrees, intersection is 205 degrees, and I'm just going to write down what the objects are and what bearing they're in. And what I might do is draw a very rough pictorial representation like this, saying that here is the direction I'm walking, that was the direction that I saw to object B, that was the direction I saw to object A. You don't need to draw that to scale. You've made a note next to it to say what the actual bearing. What you might find useful as well is to, because obviously you can look and you say, well, that object's certainly closer than that other object, so when I get my other bearings eventually, they should confirm that. So this can be a very rough, so let's just say this object C is a big rock, which is on 125 degrees, but we know that it's slightly closer to us than object A is. So maybe what then I can do is just draw in a much... Anyway, all of those bearings were taken at the start. What I would then do is I would walk along my route, and obviously our first section is going to be on the bearing that we said we were going, and as we go I would measure out how far we're going. Paces are probably acceptable for this. There's definitely some exercises you can do to get a good feel for your own pace length. Possibly something you can do just walking up and down a corridor, pick a distance of a known length, get a tape measure out and measure. Make it a relatively long length. Something maybe to do if you've got a patrol meeting at the scout hall, to actually use the length of the scout hall, and then very casually walk. It's probably the easiest thing to do would be just to measure yourself walking a set distance a couple of times and take an average of the number of paces that you take. Too often, if we just either do it once or we're sort of now very conscious of how we're walking, we actually end up changing how we walk. And it might not be a true reflection of how long our paces would be in reality. But for doing your field notes, pace is probably the best way to do it. Bear in mind, especially if it's on slightly rugged terrain, that is going to mean that your pace length is going to vary. You step a little bit further to step over the tree root, or you step a little bit shorter to make sure you don't trip over the rock, whatever the case is, especially if you're going up and down the Spruit, that might be relevant. So anyway, we're going to say we're going to head off in our direction, and we pace out. So we pace 100 paces. I'd say focus on stopping at a sensible place to stop, rather than just forcing yourself to stop on a nice round number of paces. So let's say that we actually went 103 paces, just because that took us to a good spot where we could see objects. You know, if 100 paces puts you in the middle of, right between two bushes, that's not going to give you any sighting to the objects that you want to sight. Alright, so we're going to go 103 paces, and the first thing what we're going to try and do is look backwards towards objects that we might have passed, especially the objects that we took sightings of the first time. So we're going to start. We're going to look back for that power line that we saw, and we're going to figure out whatever bearing it is on. And this time it's going to be on a bearing of 80 degrees. And So we're going to say, right, A is now going to be on a line of 80 degrees. And I'm just going to note there that this is the object A. We've already said what object A is above, so I don't need to name it every single time. And we're going to go around and pick up all these objects that we saw last time. Object B is now on 260 degrees. And object C is on a bearing of 10 degrees. And we're going to keep going. Obviously now we're going to pick up those objects that we did last time first, as well as any new objects that are relevant to us. So there is going to be a billboard, which is now on a bearing of 195 degrees. And there's going to be some other object over here. There is a hut on a bearing of 120 degrees. And you're going to wind up with a little diagram like that with all our notes. And you're going to rinse and repeat. You're going to make sure you take the bearing, what you're going to walk on, each time before you walk. Obviously the first time we just said that it was the 165 that we'd measured right at the start. But root might wiggle a smidge. 180 degrees, and we're going to go 114 paces, and so on and so forth. Nice to keep, I say, relatively regular distances between your things. So if we went 100 paces, we should go 100 paces each time. 100 paces might be far too much, depends on the density of the area, depends on what objects are in the way. There's definitely elements here where you need to use your own judgment and your own feel for the area and what's actually going to work. Especially right at the beginning, you might have a little bit of rinse and repeat, trying some things. You might actually have to go back and get some extra measurements a second time at the beginning. But we're going to now measure out 180 paces, and we're going to rinse and repeat and go on. You definitely want to make sure you've got at least 2 bearings to every object. It might be very useful to get a third bearing for objects, especially. What you might find is you get one when it's kind of somewhat ahead of you. You get another bearing as it kind of comes alongside you, and a third bearing as it's behind you. Important to remember as you go on, turn around and look back and pick up any objects that you've previously scanned to. It can be quite tempting to just get 2 bearings, kind of each pointing forward, but that's a relatively tight angle that you've got, very little difference between the bearings, and the smaller the difference in the bearings, the more likely it is you're going to end up with some error in the actual distance because of the object from you. So how would we go about using that afterwards? Well, let's pop this onto the screen and we can see how we would translate that into a map. Hang on, let me just set it up for us quickly. Just bear with me while I move some stuff around here. Right. So it's going to wind up being exactly the same process that we did. All right. But now we are going to translate our notes that we took into this. So we're going to start off with the route that we're walking, right? Or at least the first section of it. And what you might find, actually, is that when you're translating this into your final map, you might wind up with an intermediate phase first, or possibly 2 intermediate phases. Remember, our actual path is going to kind of do this. Let me just give a bit of a representation of that on the screen. Let's draw. Where are we now? So if I pop this up on the display now, so perhaps we find that the actual bearings of where we walked end up looking like this. Well, we might want to sort of draw all of those out first, and then, whoa, hang on. What we might decide is, that's a bit of a cumbersome having that big bend there. What I can do is rotate the whole thing so that our start to the end is kind of more of a straight line, and we'll work from this position onwards. Right. Remember, with our strip map, we're not caring about making sure that north points upwards, as is tradition on most maps. We're interested in making sure that our route points upwards. All right. What we would then do is, I'm just going to shrink this down a bit so that it actually fits onto our page. Is we would start off and take from the start here. Now remember, this line, doesn't matter what angle it is on the page, that is 165 degrees. So what's useful to do now is either get a protractor from your school maths set out, or you can use your base plate compass. I'll actually display how I would do that. We've got our base plate compass, and what we're going to want to do is find the bearing of our actual line, which was 165 degrees. All right, I'm going to find that particular bearing, and I'm going to place the compass on top of my map along my line, so that the edge, the upward arrow, is along that line. Okay. Then what I would do, so I've got it so that it's on my map, I pasted it along there. All right. And it's along where I've drawn my line. Try and get the needle that's there to be on your start point. All right. You want to keep that the center of the needle on your start point. And then what you're going to want to do is, holding the dial in place, you want to twist the base plate underneath it. All right. And twist the base plate until you get the next measurement that you need. Let's say it was 120 degrees. And if you've done that correctly, your line, your center point is still at the start, and now you can just use the middle of your compass and make a mark, and then go around, make all the marks that you need to do, label them as necessary, and then you can take a ruler and draw your line straight through your start point, through each of those marks that you've made. And that will be the lines of your bearings. If you want to use a protractor to do it, you can either just measure out, do some maths and figure out the difference in the angles. So if our start line was 165 and this one was 130, we know that that needs to be a 35-degree angle between them. So you can take your protractor, which I quickly dig in my stationery box here. I think I've got a protractor somewhere. I do not. But if you do have your protractor, you can use that to say, well, we need to measure a 35-degree angle. Make sure you figure out which direction it needs to go. That's where this little image is quite useful. But you can just measure out your 35-degree angle and draw your line along that way. If I pull our display back up, so what we're going to do now is insert some more lines. Let me quickly make these lines a bit darker. Right, so that was our root line. We would then grab our where is our right, so we knew from our start that we had some object that was off this way, and we had an object that was off this way, and we had an object that was off this way. Right, those are our 3 measurements that we took at the beginning. And if you look carefully at this image here, this image here, that is roughly, if I just angle it slightly, that roughly looks like what we've created there. Let me just get that roughly in line. So I need to figure out which way I need to twist this thing. There we are. And right. So those 2 roughly line up, so that's good. Anyway, we've now already drawn out that we walked on that 103 paces, which gets us to this point. And from this point, we measure some bearings to some various places. Now remember, this line here is 165. So again, we can place our needle on that point. Make sure that we've lined ourselves up with the previous line. We can either use the previous line's 165 to start ourselves off, or we can use the new line's 180 to start ourselves off. As long as you pick one and you know which one you've used. And again, we can just turn our dial around to get all the various bearings that we need, or we can again use our protractor. But we know that we took a bunch of bearings from this point. So if we come here, from this point, we're going to wind up with a bunch of lines. And we're going to wind up with one that goes there. And one that goes there. And we've got one that goes there, as well as our 2 new points that run up this way. All right, and now we've located 3 of our points. Important to watch out here. You can see there's a couple of intersections. Important to remember which lines go with which lines. So what is usually recommended you do is, as you draw each line, when we drew this line at the beginning, we would have said that it is line A, and when we drew this line, we would have said this is line A. We drew this line, we knew that it was line C, and when we drew this one, it was line C. In practice, especially when you draw the second line, you will probably already see where line C is, and you'll just draw the little bit that intersects with it, rather than drawing all the way through, drawing the entire line. Obviously, if you're just lining up your ruler, you just need to cross at the relevant point. I'd usually make sure to draw a little bit of length, so probably longer than I've drawn the C here, just so that we've got a bit of play, especially if we do a third measurement later on from another point, say we still see this A up here, we get a third measurement, then we get our sort of triangular uncertainty. It's useful to have the extra lines around. Right. And anyway, what we would then do, once we've done these things, is we would then go around and actually put in our map symbols. So A was a power line, so we're going to make that a triangle. Alright, so we now know that the power line is over there, and we can go around and delete and erase our markings. One thing that I found quite useful to do is, if you've laid out all your bearings on this and made all the notes, is to come with a sheet of tracing paper over the top and then pick up all the points that you needed to find. So then you don't have to go around doing all the erasing. You can just make the, draw yourself through the tracing paper. Alright, so we're going to remove this. Anyway, B was an intersection of some roads. So obviously we don't want to just put a little point feature there to say this was an intersection of some roads. Maybe it was a bend in a road that came past. Now, if it was a bend in the road, it might be useful to get some bearings for the rest of the road. Maybe up here, this line, we also saw part of the road. So once we've got a series of these, we can start to draw in it as a linear feature. And say, right, the road is going to go like that. And so we're going to make that a nice dotted line like this. And say, all right, that is actually the road. But we've obviously managed to pinpoint that corner there. All right. A common mistake that I sometimes see when people have been making strip maps for logs is they tend to try and make it up afterwards, looking at satellite imagery and things, which is kind of drawing it from their map. And what they end up doing is they include a whole bunch of things that you actually wouldn't see from the road. Always important to remember that the strip map is a map of the things that you can see from the path that you're hiking on. It might be relevant, it might be interesting that there is a waterfall on the other side of the hill, but you couldn't see the waterfall as you were hiking. So I would just strive you to remember to only include the things you can actually see. Anyway, when we've finished, we removed all our lines, we've put some points in, we've got the road. Don't worry about this road. If you don't know where the road goes after this, don't draw it in. Similarly from this side, you might not be able to see it. Let's put some other objects into this thing. Maybe there was a long wall that runs along here. Where's my rotate button? There we are. Maybe we took a bunch of readings. We said there was a wall along here. So we couldn't actually see what was going on here, where the rest of this road went. And maybe we can then put in, let's just put some other random objects in here. Let's see, there's some more parts of the power line over here. Right, obviously these all actually joined up because they were a power line, so let's draw that in as a linear feature. And slowly but surely this is starting to actually look like a map. Now, if you wanted to actually distort this into a map that was a strip map of this style, obviously this was just a kind of made-up area, so I'm not sure how we would actually go about doing that. But perhaps what we might say is that, well, this bit here, although we've got a bunch of corners here, there's kind of only really one bend, right? We went straight and then we turned to the right. So if we were going to finish this up, get rid of that, perhaps our final product might look something like this. Well, so there's two ways we can do this. We can either say that this is a relatively straight line, or maybe we can say that there's one bend. Let's do it as if we were going to say this was just a straight line. We're going to say, well, it's a straight line. There's a wall alongside over here. There's a power line that runs kind of alongside us over here. There are a couple of pylons along it. And there is, just grabbing a few symbols that we've got here. And let's grab this. And this was our nice big thick line. Let's just make that there. And let's add an arrow to this. Let's just put a right. So obviously, you can see this is quite a detailed map. But for somebody who's actually using this, and we wanted to say, look, hey, just follow this route, we'd say, hey, you're going to hike along, you're going to see a road bend on the one side, power line on the other side, a long wall, and whatever these two objects are. That's what you need to make sure you see as you go. And that's how this simplified map actually is a lot more readable to the user, perhaps, than this one. Especially if they're not all that interested in exact bearings and whatnot. Perhaps what was another thing that maybe we, as we were taking our bearings and measuring stuff, oopsie, not that button. Perhaps there was another path running off this way as we went along the road. We might then be able to just put that in here as, let's do this. Say, hey, look, there was a, so, hey, you're going to hike along. When you're some way along the wall, you're going to have an intersection that runs off to the left. That's, there's an intersection. The fact that it's at a particular angle on a particular bearing isn't necessarily going to be so relevant. So I hope that covers strip maps for you guys, and gives you a good understanding of how they'll work and what you need to do with them. You could definitely practice these at home. As I said, trying to make a map of the route from your, from bed to the fridge to get a snack. Practice out, try taking notes, try taking the bearings. When we actually get out into the real world, we will pick a nice strip to actually do this on. We'll probably use a section of Spruit somewhere, as I said, either Delta Park, around Greenside Hall, or one of the other halls that we decide to use. But I hope that all made sense to you guys. If you've got any questions, please drop them on WhatsApp. You can either do so now. I'll hang around here for a few more minutes to see if there are any questions and try my best to answer them. If there aren't, then yeah, we'll call it a day shortly. And I'll see everyone back at 2 o'clock for plane table maps. Plane table maps are actually giving me a lot of what we've already been through, just on a whole extra level, because we're going to be moving around trying to cover an area, and we're not going to have the luxury of being able to distort our scales at all. Right, so I'm going to sit here awkwardly for a few more minutes and let the stream catch up with me. I think it is a bit behind, but if you do have questions, please drop them and let me know. I've got a question: what is a physical map? I'm not sure I'm really following the question. Physical map, I guess, would just be anything that's actually been physically printed, as opposed to a digital map, something like looking at Google Maps or Apple Maps on your phone, or Google Earth on your PC. So we're always trying to make sure that the maps that we're going to be using are real and tangible on a bit of paper. It's definitely a preferable means of having a map, especially if you're out hiking. Can't be guaranteed you're going to have battery power, cell phone signal, anything else that you need in order to keep track of your digital maps. They're great to have as a backup, but when I was hiking in the Drakensberg in September last year, we literally just had a stack of these bad boys over here. In fact, yeah, this was exactly the map we were using, and for planning our hike. What was also great about that, if you've got the physical maps, especially if you've got maps for an area that you're not going to be hiking, so the areas around where you're hiking, that's great, especially if you need to plan, if you need to improvise and go off your original plans. On my brother's Springbok hike, they had intended to start their hike at a particular forestry station. However, there'd been heavy rains in the few weeks preceding the hike, and turned out they couldn't actually drive to the start to be dropped off. So they had to start their hike about 6 kilometers earlier than they were planning, and actually off the map. So they had to. So if they'd had the adjacent maps as well, that would have saved them some getting lost. Right, let's see if there are any other questions coming in. I hope that answered the questions that we had there. Maybe just one last thing, just on the note taking. There really is no wrong method to taking notes, provided you're getting all the information down in a means that you can use. It might even be really useful if you're doing field work like this to grab a photo of what each of the objects are. So I just wrote down here that C was a big rock. Might be useful to take a photo of big rock C, so that you can refer to it later, so you know what is going on there. Maybe just one last thing to note is on your final maps, make sure that the things you put on maps are going to be things that people will come across later on. If you're making a strip map as you're hiking, there's not much point labeling a zebra on the map, because the zebra is probably not going to be there when somebody else comes and hikes the route in 2 weeks' time. They're not going to be able to use it to navigate. It might be worthwhile sort of, if you're hiking through a farm or whatever, and say, look, there's cows in this field, that might be useful to note that often there are cows in this field, but especially if it's wildlife, a lone zebra, that's not going to be in the same spot in future. For the map, do we need 2 A4 pages? So if you're just practicing this around the house, use whatever paper, whatever scale works for you. There's not going to be much point doing a 1 in 2,000 scale map of your living room. Roll that down, use 1 in 200, 1 in 100, whatever's going to work for you. But yes, the final map, when we actually do get back out into the world, it does need to be a kilometer, and your field notes should probably be at a scale of about 1 in 2,000. So if we just flip back to the display, we're obviously going to take all our notes like this, and we're going to use them to produce something that eventually looks like this. The map that we produce that looks like this should be at a 1 in 2,000 scale, and we're going to be trying to cover about a kilometer. That means it's probably going to take up about 50 centimeters. So 2 A4 pages will be about the size you need. Obviously, with lockdown, no one is getting out to an area of a kilometer unless you are lucky enough to live on a farm, in which case, go have fun. You will eventually need 2 A4 pages to put that together. Otherwise, you can head out and grab yourself some A2 paper after the lockdown, and then you've just got one nice big sheet to put it all on. Right, I think that's it for questions. Hope everyone enjoyed the session, and we'll call it a day for now, and we'll see you all back at around 2 o'clock for plane tables.